We're going to be going over these crypto practices at 1 through 6. If we looked at this first one, we did do this one as in class together. And we talked about how if it was 9 plus 9 plus 9, that was 27. And we knew that what we needed was all of these to be the same. And the B can be a 1 or a 2. And we figured out that the correct answer of this one was 5 plus 5 plus 5 is 15. So B was 1 and 5 is A. Let's look at this next problem here. For A, this 3-digit, can you guys put the puzzles away right now? Because we need to really be paying attention to this. So the largest possible thing I could add up would be 99 plus 9, and I get 107. If I look at this A right here, can A be a 0? No, the first letters can't be 0. Otherwise, if B is a 0, it's not a 2-digit number. If A is a 0, it's not a 3-digit number. This A can be a 0, but because of this A, it can't. So that being said, A here, what is the only value that A can be? 1. Nice job. So if this is 1, then this is 1. Now we need to get a 3-digit number. If I add 88 plus 1, I get 89. Is that a 3-digit number? No. So what does B have to be? 9. 99 plus 1 equals 100. So B is a 9, A is a 1, and C is a 0. How did you guys doing so far? Thumbs up? All right, let's tackle these next two. All right, so we're looking at this problem here. Let's look again at the clues, this B. It's the same as this one. What do we know about the value of B? It cannot be a 0. What does B have to be? It has to be a 1, because we know a 2-digit plus a 1-digit can't go over 200. So B has to be a 1. And if that B is a 1, this B is a 1. All B's have to be a 1. Now we've got some fun. To make this a 3-digit number, what does the A have to be? Can I do 81 plus 8? Nope, it's not a 3-digit number. So what does A have to be?
9.
So we're talking about 91 plus some number equals something. All right. To make a 3-digit number, A is already, we know A is a 9, 91 plus 9 equals?
100.
Right, so now we know C is a what?
0.
0. Nice job. You see that?
Yeah.
All right, let's look at this next one. Who can talk me through this one? Who can tell me about, all right, since I'm back there and I can't see, you're going to be my teacher. When I call out a question, you're going to call on someone for me. Okay, thanks. All right, here we go. All right. So if I look at this problem here, I see again the 2-digit plus a 1-digit. We know we have this problem, right? So it's 108. So, this should be an 8. What a goofus I am. So that being said, what do I know the C is? Who can tell me what is a C? What does C have to be?
1.
So, and if this C is a 1, this C is a 1. All right. Next. So I need it to equal 100. We know we've got this problem. If I add 81 plus 8, I get that 89. So A, what do I know about A? What does A have to be? 9. Nice job. So now I'm talking about adding 90 something plus 9 equals 1, 1. Let's look at this D here. Now, can D be a 1? No, because C is already a 1. Can D be a 0? Yes. Can D be a 2? No. 2 is too high. There's no way to get it. So D can only be a 0. So 90 something plus 9 is 101. Now we're going to do a new strategy called a work backwards. Now if forwards is addition, backwards is going to be the inverse. The opposite of addition is subtraction. So 101 minus 9 is 92, which means B must be a 2. Nice job. Actually, I should cross off the things that are wrong so we know not to. There we go. All right. Let's look at this bottom one down here. This is a gorgeous one. For the first time now, we are seeing 2-digit and 2-digit. The largest 2-digit number we have is 99. And if I add 2 99s, I get 198. Which means if B cannot be a 0, because then it's not a 3-digit number, B must be a 1. And if this is a 1, this is a 1, this is a 1, and this is a 1. C here. Can C be a 1?
No.
No, because 1's already taken. Can C be a 2?
No.
No, because well, yeah, we could try to get some there. All right, let's try this out. Who thinks they can figure something out for us? And I'll give you a hint. I heard someone whisper it. Here's a clue. What do we know about C? Who can help us out and tell us about C? My teacher assistant will assist me. C has to be a 0. How do you know that? Yeah, you can. Yeah, so this 1 plus something is 1. It has to be a 0. So if that was, there's no other way. If you did it, there's no other way. So now we have something 1 plus 10 equals 101. We have another work backwards. So we're going to do some subtraction. 101 minus 10 is 91. So A is a 9. Now we get to have some fun. Are you ready? So AB plus BC equals, okay, AB plus CB equals BA. Yucky, yucky, yucky. Okay, there we go. Now it says there are 3 solutions, but in fact there are 5, but only we talk about this one rule. If A is a 0, is that a 2-digit number? No. So A cannot be a 0. If C is a 0, is this a 2-digit number? No. So C cannot be a 0. If B is a 0, is that a 2-digit number? No. So B cannot be a 0. So knowing that, there are only 3 solutions. If these could be zeros, there are 2 other solutions, but this is a rule. So I wanted to know, following that rule, what are 3 solutions? All right, my teacher is going to call on someone for me. Okay. Well, then what was an A? And a C is a 2. So let me write this out. So that would be 47 plus 27, 74. And we look, we've got these 3 have to be the same. These 2 have to be the same. Check. Yay, that's one way. Who's got another way? All right. Okay. So this would be 26 plus 36 equals 62. These three are the same. These looks good to me. We'll give that one a tongue and some hair. All right, one more. Wait, B's are what? 8, okay. Okay. All right. So 68 plus 18 equals, these three are the same, those three looks fabulous to me. Those are our 3 solutions. And now we get to look at tonight's homework. So I'm going to show it to you. I'm going to give it to you just a minute, but please look. You are getting 6 problems on one side. So 1, 2, 3, 4, 5, and 6. And then on the back, you have 2. You'll notice the top one has 4 solutions and the bottom has 5 solutions. And I give you multiple writings of it just so you have lots of place to show your work. Best of luck to you. Let me hand those